This is pre-calculus, notes on 1.6, explicit form of a geometric sequence. Here I've got the recursive form of a geometric sequence, and I'm going to start out by using this recursive formula to find the first 5 terms. So it's shown that the first term is 6. And to find the second term, I'm going to multiply that by 3, which is going to give me 18. And I'm going to go get my calculator. To get the third term, I'm multiplying 18 by 3. It's 54. 54 times 3 is 162. 162 times 3 is 486. All right, so we've used a recursive formula to find the first 5 terms of this geometric sequence. Okay, now what I have is an explicit sequence. Okay. And in an explicit sequence, I am finding the terms using n is the term number. So if I were to plug a 1 in, I'm going to find my first term, which is 6 times 3 to the power of 1 minus 1 is 0. 6 times 3 to the power of 0. Anything raised to the power of 0 is 1. So my first term is 6. To find my second term, I've got 6 times 3 to the power of 2 minus 1. 2 minus 1 is 1. So this is 18. To find my third term, I've got 6 times 3 to the power of 3 minus 1 is 2. So that's 6 times 9 is 54. So the third term is 54. To find my fourth term, I've got 6 times 3 to the power of 3. That's 6 times 27. I'm getting out the calculator. 6 times 27 is 162. And to find my fifth term, I've got 6 times 3 to the power of 4. 3 to the power of 4 is 81. And 6 times 81 is 486. Okay, so hopefully you noticed as we were doing this that the numbers were the same as the sequence we did in the previous slide recursively, okay? So we've got 2 different ways, these are the exact same terms, we've got 2 different ways to represent a geometric sequence. We can do it recursively or we can do it explicitly. Okay, this formula that formula is for explicit form of a geometric sequence. Okay? So you're just going to substitute your use of 1. Use of 1, of course, is the first term. And your common ratio, R, into that formula to write the generic formula for the geometric sequence you're working with. So underneath the line, I've got a problem. Write the explicit form of a geometric sequence where the first 2 terms are 3 and -3/4. So there's 2 things I need to know. I need to know my use of 1, which was given to me. That's 3. Now to find my common ratio, I am going to divide the second term by the first term. So I'm going to take, excuse me, I am going to take -3/4 and I'm going to divide 3. To divide fractions is the same thing as multiplying by the reciprocal. And when you're multiplying fractions, you can cancel common factors. So my common ratio is -1/4. So I only needed to know 2 things to write this formula, and now I know them. I'm just making myself a little bit more room. I'm going to move this down, I'm going to move this down. Okay, so now in blue, I'm writing my formula. So u sub n is equal to u sub 1, which is 3, times the common ratio, which is -1/4 to the power of n minus 1. So that is the formula for the geometric sequence that was described. Find the first 5 terms of the sequence. Well, you already know the first 2. Okay, so I am going to now multiply, this is geometric, I'm multiplying each term by -1/4 to find the next term. So -3/4 times -1/4 is a positive 3/16. Remember, negative times negative is a positive. 3/16 times -1/4 is -3. 4 times 16 is 64. And then that term, -3/64 times -1/4 is positive 3 over 64 times 4 is 256. So there's the first 5 terms of this sequence. Okay, signs of a geometric sequence sometimes alternate. And in the last sequence that we just did, okay, they were positive, negative, positive, negative, positive. And that's what we're talking about. Signs of a geometric sequence sometimes alternate. There we go. Signs of a geometric sequence sometimes alternate. Signs of an arithmetic sequence never alternate. If you're adding the same number over and over and over again, you're either going in the positive direction or in the negative direction. You cannot bounce back and forth. So if you're taking a look at a sequence and the signs are alternating, you know it cannot be arithmetic, but that it might be geometric.